My name is Ron Snyder. This is my colleague Steve Coffman. We're from Ithaca. Here we go. So who is Ithaca and who are we specifically? So Ithaca is a nonprofit. We serve the academic community. Folks that have been through college in the last 20 years may know of JSTOR. JSTOR is a very commonly used archive of journal content that many universities subscribe to. So JSTOR is probably the most well-known part of the Ithaca umbrella, but all of our divisions or component companies do the same sort of thing. And we serve the scholarly community, and we provide academic resources or archival services in the case of Portico. So wow, yeah, this is not great quality on the resolution, but we'll work through it. So the JSTOR Labs team is where Steve and I come from. So we represent JSTOR Labs. This is a group that's been in existence for going on 5 or 6 years now, and much of what we do is explore different ways in which we can make JSTOR content in particular, but more generally the content in the Ithaca family more accessible to scholars and researchers and educators. So looking for innovative ways to provide better access to the content. And most of our work has been in the discovery realm, providing better ways for search and discovery. So in this presentation, what I wanted to talk about, so there are 3 parts to it, and I'll cover the first 2, and then Steve will dive into the third part, which is getting into some of the details of how we're doing our hosting of our knowledge base. So I'll talk about Wikibase and our rationale and the reason that we selected that for our knowledge base. And also, well, I thought about doing a demo, but I think I'll hold off on the demo and I'll just stick with the charts. But if there's interest in seeing the demo, I'd be happy to do it maybe after the presentations this afternoon. It's a pretty good demo, and it may kind of illustrate some of the points I'll try to make with the slides. But I think the logistics and the time involved of doing the demo probably are a bridge too far for what we have here, so I'll not do the demo. So I think the question that I posed in the title, why Wikibase, is probably 1 or 2 questions downstream from where maybe we should start. And so maybe the first question is, why a knowledge graph? Why linked open data? And then once that question is answered, then the reason for picking this particular implementation of a knowledge graph, I think, will kind of lead us into the presentation that I had planned for. So the things that we typically have done have been trying to connect users to content, and increasingly more of our work is trying to connect content to content, and in many cases, primary source content to secondary literature, and then, so a lot of this relationship identification that is difficult using more traditional technologies like relational databases, and we've used things like document stores, MongoDB and Cassandra and those sorts of things. And while those are very good technologies and have worked in many cases, they start to fall short when you're trying to reuse things and tie many things together. So we've started to think more about the use of linked open data and knowledge graphs as our, kind of our go-to data representation. And so I'm going to talk about why we chose Wikibase and how we're using it through the lens of a particular project that we're working on now. And this is very much a real-time sharing of what we did, why we did it, how it's going. I mean, a lot of this is still work in progress. We're hoping to release this, I'll put air quotes around release, and we don't ever actually release something. We just make it available, and people can then play with it. So it's a prototype. It's something that we learn from. But we'll be making this more widely available within the next couple weeks. So this is still work in progress, but I'll share, current observations and some of the rationale behind it. So this particular project is what we call the Interview Archive Project. This is a collaboration with the Kuhnhart Film Foundation, and it's partially funded by HBO and the Bank of America. And the idea here is that, well, the the film or documentary King in the Wilderness was released by HBO last summer, and it's a very powerful documentary that explores the last 3 years of Dr. Martin Luther King's life, some of the struggles he was going through, and it's told through interviews with people that were involved with the movement at that time. So we're talking about, Andrew Young, Dorothy Cotton, John Lewis. There were 19 individuals that were interviewed for this documentary, and like with a lot of these kinds of things, a lot of actors say, well, the best stuff was put on or was left on the cutting room floor. Well, in this case, I don't know if it's the best stuff, but there's a lot of good material that didn't make the final product. So there were 30 hours of interviews, and in the film itself, there were probably less than 20 minutes of actual clips from the interviews. So the task that we had was to take that content that didn't make the documentary and make it available for teaching and learning purposes. So this will be an open source, an open access product that we'll release. And we'll have two parts. There'll be a knowledge graph that will be openly available, and there will be a web application built on top of that. So this will be one application of many possible ones using the same data. So people that are interested in maybe exploring other ways to interact with this data will have access to the knowledge graph, and they can do their thing too. This may be hard to see, but the key elements of the application, and these are mock-ups, but the actual application looks very, very close to this. And as I mentioned, I can do a demo if there's interest. But the idea was to, through a search interface, be able to search for mentions of entities, and there are, I think, somewhere over 1,200 entities that were identified in the transcript and in the audio from the interviews. And so we've organized those. So if you're interested in this case, the entity was Montgomery, Alabama. If you're interested in mentions of that, we've cataloged all the mentions of that in the interviews, and you can kind of navigate to that, and you can click through, and that will take you to what's basically the main page. And kind of the vision for this, for those of you that might remember, the pop-up videos that MTV did back in the 90s, where they had a music video, and they would have these bubbles that would pop up with these factoids or anecdotes or whatever. It's that kind of idea. So the idea here is that we'd have the video playing, the transcript would scroll up, and then for each section in the transcript, we would identify the entities that were mentioned, and a person could click on one of these entity bubbles and get some background information and also pointers to other information. So that would be information from the JSTOR archive, so journal articles and such, maybe some images from our ArtStore archive. So it was a way to kind of navigate through that material in very rich and meaningful ways. So this implies a data model or set of interconnected resources where we have the transcripts that we would use as the source material, and these transcripts are annotated with the QIDs. So in the Wikidata presentation earlier, there was mention about these unique identifiers that are used in Wikidata. So all of these transcripts have 0 or more QIDs associated with individual segments, and those are loaded into our knowledge graph. And then those are connected to JSTOR and ArtStore content. They are connected to Wikidata through the QID. And once we have that connection, then we can also connect that data to other resources. Wikipedia is the one that we use for some of the background info. But there are many other things we could leverage from the Wikidata entity, such as the Library of Congress identifier. There's just no end of things we could leverage there. But in the current form, we're just using the Wikidata link. So what we were looking for in a knowledge graph, and this is kind of leading to why we picked Wikibase. I mean, there are many good ones out there, and we've actually used a few others. We're currently using Neptune for another project, but we've used BlazeGraph for a project. We've used the Jenna Fuseki from Apache. We've used that before, but Wikibase worked better for what we're imagining down the road for new projects, in that it's, first and foremost supports a high-performant, triple store with, Sparkle queries and federated Sparkle and such. But the thing that was really appealing was the ability to use the web interface. So a lot of this relationship mapping of these entities is going to be a combination of both machine and humans, and we'll need the ability for humans to, if not to add the information, at least to audit it and modify it and correct it and so forth. So we needed a very easy to use interface that was accessible by a wide variety of users with different technical capabilities, and so Wikidata provided that. It also provides some version of a full text search and version tracking. It provides a nice API for both the SPARQL queries, but also for accessing the structured data in the backend database. And also provides a degree of prototyping, which is also one of those things that we viewed as a nice to have. Wasn't a requirement, but was something that was very desirable. So after thinking about this, we did pick Wikibase because it did provide, I think, the best out-of-the-box solution, with this back-end SPARQL capability, but also with some of the other capabilities that are provided through the Wikimedia base on which the Wikibase is built. So what is this exactly? Wikibase is built on Wikimedia. Wikimedia is the framework used by Wikipedia and many of the other Wikimedia Foundation projects. And it's an extension that provides a triple store and some web-based interfaces for interacting with the data. I'm going to quickly go through these last few charts so I leave Steve some time. So what we have ended up with after this, I hate to call it evaluation, because I think going into this, we kind of knew we wanted to do the Wikibase thing, but we did go through a bit of an exploration of the different options, and at the end of the day, this seemed to be the best fit. And so we're using that in a self-hosted version of Wikibase, and Steve will talk about what that entailed and where we're at in that process. And we also have a rich JavaScript client application that we use for the application itself that ties into the Wikibase backend. So we're using the structured data in Wikibase with the triple store data that is generated from that in this view application, which is a web application, and it in real time queries Wikidata, pulls data from Wikipedia, streams videos from YouTube, and also pulls data from JSTOR for that background information. This isn't terribly legible, but the idea is that we have these transcripts are annotated with the QIDs that are ingested into the Wikibase, and then we have on the right, that's a representation of one of the Wikibase entity pages that has the relationships between this particular video segment and the mentioned entities. And this is more of just showing the linking between the various entities. Okay, so with that, I'm going to turn it over to my colleague Steve to go into some of the details about what it means to host a Wikibase instance and how we're doing that and what some of the observations have been up to this point.
Hello. So wait a sec here. So what I'm here to talk about is if you're like me, then software is both the solution to and cause of all of your problems. And one of the things that we were exploring, the context of our specific problems base, was that we are actually trying to be able to have prototypes that may only get a few people initially, but they may become successful enough to, for instance, the JSTOR site, we get over 100,000 unique visitors per year. And so to be able to have that sort of scalability, there's a lot of different, it's hard to engineer that. And so I recommend that if you have that sort of context and problem, that you rub some Kubernetes on that problem set. Because one of the things that I really enjoy about it is that it provides a self-healing basis where individual components can have very fine-grained and accurate health checks and automatically restart and recover in different ways. if you're relying upon humans to provide you the resilience that operating sophisticated and complicated applications and infrastructure, it's not actually really resilient, because those humans can fail, they can be on vacation, the wrong two people can talk. If things are fully automated in a way that you feel confident leaving, and you know that for a pretty good set of time without any human intervention, it's going to be fine, then you're doing the right thing. And Kubernetes really provides that in a lot of different ways. You can, not only in the infrastructure level, where the cluster itself can detect problems with individual servers that it's running on and automatically deschedule it, but also in different aspects of that where the application itself like I said, are being restarted and scaled in a way that doesn't affect other people. Part of that is that it has really great monitoring tools, both looking at individual fine-grained logs and also looking at metrics, very detailed metrics, and that are very useful. And they have nice dashboards that just can come out of the box, where you can actually see exactly the kinds of things that you, as a reliability engineer, really want to care about. And you can take that all the way to using service meshes, which provide extremely high fidelity when you're looking for observability. And you can even have then nice detailed service graph diagrams. I know that people here might be interested in graphs, but you can get graphs of graphs. So that's, as long as you can go inception and get meta that way, then you're doing well. The other thing that we found is that instead of waiting for Amazon EC2 services to spin up and take 10 to 20 minutes for Puppet, Chef, or Ansible to start to actually configure it and get those servers ready for you to use in the way that you want, we can actually rely upon the servers that are already there for the Kubernetes cluster and scale that based upon our actual usage. So we typically only have to wait a few seconds for a deployment or a change to a particular configuration or application or infrastructure to take effect. So we don't have to wait for minutes to see that. We just fire it off, and by the time we go look to see what we expect is already there. So that's actually quite pleasant. It also provides automated rollbacks, so that if we make a quick change and that change was catastrophic in some way, it doesn't actually hurt us because it's automatically rolled back and we can see, oh, whoops, I probably should have put a semicolon there or whatever. That scalability provides us with a level of optimization similar to like a giant distributed operating system playing a game of Tetris, where it's going to find the right shape of available resources and schedule those different applications to fit there optimally. So we don't have to spin up a large cluster that will be there for when we want to go through the entire JSTOR corpus and train our models. We can actually use it exactly as we want on demand. Or when a large number of people, something goes crazy on Twitter and everybody's coming and looking at this application and it goes viral, it will actually just elastically deal with that in a way that is actually very simple to understand from an operator's perspective. The last point is, I think, the most important, is that the convergence that Kubernetes allows. We have used, we've been in the cloud since 2014, and we've used pretty much every Amazon technology or managed service that they have. And we chose to actually use Kubernetes on AWS because the best practice for a finite run to completion task, like processing something or doing a model, or the best way to run a stateless web application, the best way to run a stateful database like BlazeGraph, those are actually very disparate sorts of tools and technologies in Amazon or elsewhere. And the thing with Kubernetes is that you can actually write a declarative, nice, simple YAML file that looks pretty much the same for all of those things. And everybody then on the team is able to talk in a very ubiquitous language about the containers and the configuration. And whatever you've learned in running one class of workload, you automatically can apply that to other classes of that. It has allowed us as a team, despite the fact that we have inside of our organization a few hundred engineers, a few thousand servers, and a few million visitors, we can have a two-pizza box team that's cross-functional, and the graphic artist can go ahead and actually do a new set of deployments on Kubernetes without really having to worry about it going bonkers or doing anything crazy. Or we can have anybody from in the team can actually do pretty much anything, and it's very empowering and very liberating for people to have that experience. And that's one of the things that I think is so attractive about Kubernetes. So thank you for your kind attention.